Hello, can I come in?
Sure, come on in.
Hello, Professor K. How are you?
Fine, very good.
Where does meteorite come from?
Well, there are several things we have to get separated. First of all, when a rock from outer space hits the atmosphere of the Earth, it burns up by friction, and that's called a meteor. So, a meteor is that streak of light created by a rock from space burning up in our atmosphere. When it hits the ground, it becomes a meteorite. Now, when the rock is in outer space, deep space, we call it an asteroid. So an asteroid is basically a rock in outer space. They usually circle around the Earth, circle around the Sun between the orbit of Mars and Jupiter. So we think there was a failed planet, a planet that never quite gelled between Mars and Jupiter, and the remnants of that created the asteroid belt. But when these asteroids or these rocks hit our atmosphere, they burn up due to friction and they become meteors. Now, comets, on the other hand, are totally different. Comets are basically icebergs in outer space. While meteors basically consist of rock, comets consist of ice and rock, and many of them come from even outside the solar system in what is called the Oort cloud. So comets also have a tail, a beautiful tail in outer space that can linger for weeks in our atmosphere. However, in outer space, but meteors only have a tail when they hit the atmosphere of the Earth, and then they burn up within a matter of seconds. Comets have a beautiful, gorgeous tail that can linger for weeks in deep space, and it's caused by sunlight hitting the surface of this icy object, the comet, and causing the ice to sublimate or turn into ice crystals. And this stream of ice crystals becomes the tail of a comet.
So, how often do meteorites hit the Earth?
Well, there are several categories of meteors and asteroids that can become dangerous. One is the city buster. These are objects that hit the Earth once every 100 or 200 years, and they will be enough to knock out a city like London or Washington, D.C. And just within the last 200 years, we've had two of these city busters hit Russia. In Tunguska, Russia, in Siberia, and also more recently, Chelyabinsk, also in Russia. So these objects, before they hit the atmosphere, are roughly the size of an apartment building. They burn up in the atmosphere and they land on the Earth. And if they hit a city, it could definitely create more devastation than the Hiroshima bomb. They hit the Earth once every 100 years. Most of the time, they land up in the oceans, so we don't even notice them. We notice them, of course, when they hit Tunguska or Chelyabinsk in Russia. Then, more of a threat are the nation busters. They could take out Germany or take out England or take out most of the eastern part of the United States. These objects hit the Earth perhaps once every few thousand years, and they could be, for example, almost a mile across. Then we have the planet busters. These are objects 5 to 10 miles across, like what hit the Yucatan of Mexico 66 million years ago. These objects are big enough to knock out life as we know it on the planet Earth. And they hit the Earth perhaps once every 50 million years. Mm-hmm. The last one, 66 million years ago, we think knocked out the dinosaurs. So we've now been able to recreate what happened when this object hit the Yucatan of Mexico 66 million years ago. First, if you were a dinosaur in Mexico, you would have seen this flash of light and heat. This light travels at the speed of light and therefore is almost instantaneous. And so that was the initial shock wave that the dinosaurs encountered. Then after that comes the blast. The blast is not electromagnetic radiation or heat. It's basically the accumulation of air molecules being pushed by the radiation from the bomb. The blast is enough to flatten objects for hundreds of miles
Mm-hmm.
from the impact point. Then after that, we have the tsunami, because if it hit the ocean like it did 66 million years ago, it creates a tidal wave. This tidal wave could be hundreds of feet tall, and it would inundate most of Mexico. And also, then hours after the impact, now, hours to days after the impact, you have the debris showering down from the impact like a meteor storm. So you have small rocks that were flung into space by the impact, gradually coming back down to Earth. So we think that this 1-2 punch is what knocked out the dinosaurs. But what really did them in took place over the next several months. Because as the temperatures dropped, then animal life and plant life began to die. When the sunlight was covered by the cloud of dust and debris, it lowered the temperature of the earth and lowered the amount of sunlight. So plants died. When plants died, then the plant-eating dinosaurs died. And when the plant-eating dinosaurs died, then the meat-eating dinosaurs also died as a consequence. So we think that life on the earth with the dinosaurs died out sequentially, one after the next after the next. However, some dinosaurs and some organisms survived. For example, the dinosaur that survived were the birds. Birds apparently are descended from dinosaurs. They survived. And also mammals. Mammals are warm-blooded. They can adjust to cold temperatures, while cold-blooded organisms slow down to the point where they can't forage for food and they starve to death. So cold-blooded animals probably did not do very well. And we think, though we cannot prove, that the dinosaurs were cold-blooded. But the warm-blooded animals could maintain a high body temperature, even with the cold gripping the earth, and so mammals survived.
Mm-hmm. So, how do some meteorites include rocks from the Mars or the Moon?
We used to think that the meteors that we see hitting the earth just came from the asteroid belt between Mars and Jupiter. But then when we analyzed some of these meteors very carefully, we looked at their mineral content and we looked at their air content. Much to our surprise, we found out that they are identical to what we find on the planet Mars. So we now realize that the solar system is sort of like a ping pong game, where debris from meteor impacts plow into the Moon, Venus, Mars, send debris into outer space. The debris then drifts for millions of years in deep space until they land on the planet Earth. And when they burn up on the planet Earth, then we can analyze them and show indeed that they came from the Moon or they came from Mars. So we know what Mars rocks looks like, and we know what the mineral content looks like, and we compare that with what we find, and bingo, we find that there is in fact Martian rocks on the Earth. Now, of course, we want to retrieve rocks from Mars using our rovers, but we already know that Mars rocks have landed on the planet Earth, which also means that maybe Earth rocks have landed on the Moon, or Moon rocks have landed on Mars. Mm-hmm. So there could be a cosmic ping pong game with debris going back and forth between the planets of the solar system.
This is really interesting. What attracts asteroids to the Earth or other planets? Yes.
Well, gravity. Gravity is the universal force that Isaac Newton worked out, and gravity extends even beyond the orbit of Pluto. So gravity is the force that holds the asteroid belt together. But once in a while, asteroids collide. They have irregular orbits, and as a consequence, sometimes they drift out of the belt and they can land on the planet Earth. Now, how many of them are there? Well, beyond the size of a football field, we think could be tens of thousands of objects that could hit the Earth, causing considerable damage. However, probably none of them will hit the Earth within the next 100 years. Beyond that, it's still a little bit conjectural. So for objects bigger than a football field, we track them. Their orbits are regular. We can predict their orbits because we have Newton's laws of gravity. And we know, therefore, that the Earth is probably safe for the next 100 years. However, when you start to talk about meteors smaller than a football field, then there could be millions of these objects. We don't track them, so they are potentially dangerous, and they're the ones that catch us off guard. Every once in a while in the newspaper, you read that an object that we didn't know existed came slowly barreling by the planet Earth, but missed. We were blissfully unaware of this for time immemorial. We never thought about this. But now that we track these things, we suddenly realize that they go by the Earth all the time. Of course, most of the time they miss the Earth. The only danger we think is perhaps beyond 100 years. But we're shocked to find that for small rocks, smaller than a football field, there's lots of them, and they do come by the Earth rather frequently.
So let's say that an asteroid larger than a football field is coming towards the Earth. Then, what actions are we going to take?
Well, there is the asteroid Apophis. The asteroid Apophis is 1,000 feet across, larger than a football stadium, and we're tracking it very carefully. It's going to make a pass in 2029, the first pass. It'll come so close to the Earth's atmosphere that it'll actually go through the atmosphere below our satellites. Get this. This object, a rock 1,000 feet across, bigger than the Rose Bowl, will actually be below our satellites. That's how close this thing will graze the Earth in 2029. However, the recent computer data shows that it will probably miss. However, when it misses the Earth, it'll go through the atmosphere, and we don't know what's going to happen to the trajectory of the object. Because, of course, the atmosphere has friction. Friction is unpredictable. We cannot use Newton's laws of motion to calculate how friction is going to affect the asteroid. So it's going to make a second pass in 2036. On that second pass, it could even come closer to the planet Earth. The latest data we've seen indicates that it'll probably miss again in 2036, but it's going to come around again, around 2080 something. It's going to come around again. So every few decades, we have to make new measurements of Apophis because it could actually hit the Earth within, let's say, a 100, 200 year time frame. It could actually hit the Earth.
So what are we going to do if an asteroid hits an Earth?
Well, the worst thing to do is to try to blow it up. For those of you who've seen the movie Armageddon, Bruce Willis took the space shuttle and blew up the object. What's wrong with that? What's wrong with that is, first of all, the space shuttle has been decommissioned. There is no more space shuttle. The second mistake is that even if we did have a space shuttle, it can't reach deep space. Most of our rockets simply go around the planet Earth. They never reach orbit beyond the planet Earth, and so we're basically defenseless. We're like a sitting duck if Apophis were to come close to the Earth and perhaps strike the planet Earth. So what else can we do? Well, even the Chinese are interested in this. The Chinese are thinking of using their Long March rocket to nudge the asteroid out of the way. In other words, direct impact. Instead of blowing it up, which would create lots of mini asteroids, more dangerous than the original asteroid, so you don't want to blow it up, you nudge it out of the way. That's the leading proposal now. So you basically nudge it by impact. You have a nose cone, it hits the asteroid and pushes it out of the way. The farther away you do it, the better it is. Because if you do it close to the Earth, these objects travel very fast as they go through the inner solar system, very hard to deflect. Farther out in outer space, they're not traveling very fast, you could push them out of the way, and many months later, they would miss the Earth.
So, thank you very much, Professor K.
Well, it's been my pleasure.